Okay, let's look at problem 2.85 for this is statistics. Basically with this problem you're given a data set. Here's your data set and we're to construct a histogram. Well, with a histogram you need a frequency distribution which shows your class widths and shows how many different measurements are in each class. Well, here this is given to us, but we have a problem. Notice it says annual saving from 0 to 10,000, K is in thousands. So from 0 to $10,000, you had 162 companies that had an annual savings of from 0 to $10,000. From 10,000 to 25,000, you have 62 companies. 25,000 to 50,000, you have 53 companies that have an annual savings of that amount. Well, we have an issue here. When we graph the data, normally when you construct a histogram, your widths are exactly the same. Well, notice my class widths here. This is from 0 to 10. This is from 10 to 25. Well, this one is with 10. This is with 15, with 25, 50. There's a problem. We have to adjust. We have to have an adjusted number of companies because this is the data that they gave us. If we had the original data, then we could just reconstruct and redo the histogram but in frequency distribution. But since we don't, we're going to have to use the data that was given. Well, since I have the data, this is all I have, I'm going to adjust. I'm going to start with 1. And they explain this here. They have a little formula written out, but I'm going to show you where they get the formula from. Basically, what we're going to do, I know 0 to 10 is the smallest class width. Okay, I want to adjust everything to this height, or this width of 0 to 10. So now I'm going to write out a little equation. Okay, since I want to adjust everything to this width, well, I want this width to be in proportion to a width of 10. So I want to go this value, which is the width, times what equals 10 to adjust it. Well, let's write out a little formula for that. Basically, if I look here, this class width is 15, right? 25 minus 10 is 15. If I go 15 times what is equal to 10. Why did I choose 10? I just chose the smallest class width. To be honest, you could have chose any of them and adjusted to that height, but we're gonna adjust it to the smallest height. Well, here 15 times what is 10? I don't know. Solve this. Let's call this x. Makes more sense to us. Just divide both sides by 15. So x is equal to 10 over 15, which can reduce to what? 5 goes into 10 twice, 5 goes into 15 3 times. Well, if I go 15 times 2/3, it equals 10. Okay? Well, I've adjusted my my width of 15 to 10 now, because 15 times 2/3 is 10. Well, I got to do the same to this. I'm going to multiply 2/3 times 62 to adjust the height. If not, it's going to make your data look like something that it shouldn't look like. It's going to represent something that's not there. Okay, if we were to formally write out, this is the formula they have here, the different calculations. I'm going to pull up an Excel document. I have the data already downloaded here. Basically, this is my adjusted heights. This is my actual heights of the company with this original width here. Well, watch what I've done here for my formula. I went 10 divided by 25 minus 10, which happens to be this value, which is 15, which is going to be the 2/3, times the 62. That's going to give me this value here when you multiply it out of 41.33. Well, here, if I continue with this same pattern, and this will be problem 2.85 part 1. We'll continue with part 2 in a moment.